Roger, repeat loud and clear.
There are literally hundreds of organizations worldwide who are working on future Mars expeditions, everybody with their own specific focus and niche. In our case, it's the surface operation and the search for life.
We're not training astronauts, but we're figuring out how they should be trained. We're trying to write the field manual. Nothing can stop an idea whose time is coming. This idea is coming.
It's not a matter of if, but when. Mars enthusiasts are certain humans will explore and eventually settle on the red planet. In the past, space missions have been led by governments, but now we're seeing more entrepreneurs and small companies joining in. I'm Emma Keeling in Innsbruck, Austria, where a group is preparing their astronauts for a very different kind of Mars mission.
Human beings have not yet landed on Mars, but when they do, they'll be using data from research simulations carried out on Earth.
What is the Austrian Space Forum? What is its purpose?
We are a research entity, which means our product, if you say so, is knowledge. It's the papers, it's the journal articles and the conference contributions. Basically, we are learning how to ask the right questions. When one day people will go to Mars, they know how to do it in the most efficient and safe way possible.
NASA is also watching you.
Yes, we have also professional observers programs where we invite and we have people from major space agencies from Germany, from France, from European Space Agency and NASA, so to join us and see what we're doing, because we don't want to do blue sky research without any connection to the major agencies. So we might not have the means for the big budget projects, but we are fast. And at this stage of Mars exploration developments, it's important to be able to fail fast, fail cheap, to have a steep learning curve, and that's what we do. We are able to do things major big agencies are having a hard time doing because of the process that they have, but we can try out the wild and the crazy ideas, and that's how we learn.
Dr. Robert Wild is one of the forum's newly trained so-called analog astronauts, which means he conducts ground-based real-time simulations of Mars conditions instead of using computer modelling.
Oh, you're arriving in style. I had to walk. How are you this morning?
Great, nice to meet you.
Hello. Big day ahead.
Absolutely.
Well, it is for me anyway. I guess you're used to this.
Robert is hoping to be selected for a 1-month mission to the Negev Desert in Israel next year. It will come down to whether his expertise is needed.
Come on.
Thank you.
Contact, Hawaii contact, 100% keen and modulation is go. Roger, repeat loud and clear.
I play a small role. I'd like to think it can be an important one. The drive to get to Mars it involves a lot of people and involve a lot of work from engineers, from scientists, and from people like us, and everybody working together, everyone doing their own small part will eventually make this happen. And so I'm happy that I can be part of that.
Mars is the second smallest planet in the solar system after Mercury and lies 227.9 million kilometres from Earth on average. It changes because the two planets orbit the Sun at different speeds. This also affects the total time it takes to get there, which is between 150 and 300 days, depending on the speed of the launch. And for the same reason, communication has a delay of up to 22 minutes. Which is far quicker than the time it takes to put on the spacesuit.
So this is 3 hours.
Yeah, with a really fast and trained team, it can be a little bit faster, but that's about the time it takes.
Slowing, well, obviously a camera crew is going to slow you down today. So patience, that's a big part of being an astronaut, is it?
Well, it's a big part of everything, I think. Also a scientist, yeah.
The team meticulously work through a checklist.
Why have you got the supports here? Is that, you're going over rocky terrain, that's to keep your legs?
No, actually. So when you're in a real spacesuit, in an area of low pressure on the outside, right, you have air pressure on the inside so you can breathe, and that makes the suit act a little bit like a balloon, right? It balloons out, and that means that whenever you move, you're working against that air pressure. you're pulling against this balloon, and so it restricts your movement, and that's what we have here in order to simulate that restriction. This is actually pulling my legs straight, just like it would be in a real spacesuit.
Right. So you wouldn't have, if you were up in space, you wouldn't have.
That's
this.
correct. This is to make it more like wearing a real spacesuit.
And what is this material? Would this be the kind of material that an actual suit would be made out of, or this is just for Earth?
This is just for this suit. However, it is a mix of, correct me if I'm wrong, it's Kevlar and Panox, with a reflective and conductive coating on the outside. The reflective coating helps keep the heat load down, because if we're going to Mars-like environments on Earth that tends to be deserts, and so if you have a lot of sun, you don't want to heat up too quickly.
You'll be cooking in there.
Yeah, exactly. So this definitely helps with that.
Thousands of years ago, all they knew, all they could see, was a fiery red dot in the sky. Unlike the stars, which stay in fixed positions, Mars and 5 other bright lights moved through the sky. In fact, planet is the Greek word for wanderer. The Greeks named it Ares, after their god of war. The Egyptians described it as the Red One, and the Romans called it Mars. The Babylonians studied astronomy as early as 400 BCE. They developed advanced techniques to predict the future position of the red planet. But it wasn't until the 16th century, when Nicholas Copernicus proposed a sun-centered model for the solar system, that man edged closer to understanding Mars' irregular movement. Johannes Kepler revised this. One of the 3 major laws of planetary motion he discovered was that planets move in elliptical orbits with the sun at one focus. By the time Kepler published New Astronomy in 1609, Galileo Galilei was preparing a report on his observations of Mars with a primitive telescope, the first to use it for astronomical purposes. The planet has long held fascination for observers because its surface appears to change. Astronomers needed to get closer, and the telescope brought it into focus. Christian Huygens used one to make the first drawing of Mars to show a definite surface feature. But it was over 200 years before Giovanni Schiaparelli compiled a map of the planet using names based on classical geography or, in some cases, descriptive words. Most of these place names are still in use today. After World War II, liquid-fueled rockets showed potential as transportation, which made interplanetary travel a possibility, and Mars was one of the early targets. In 1967, the USA's Mariner 4 completed a flyby, returning photos of the cratered surface and confirming the atmosphere was mostly carbon dioxide. 4 years later, Mariner 9 was the first Mars orbiter, revealing detailed views of all of Mars. Missions continued to gather data, but it took until June 19, 1976, for NASA's Viking 1 to make history by becoming the first mission to land a fully operational spacecraft safely on another planet. Finally, humans could virtually reach out and touch what had been a fiery ball in the sky. Mars enthusiasts believe it's only a matter of time before humans land on the red planet. On Mars, a spacesuit would need to protect the astronaut from an average temperature of -60 degrees Celsius. The atmosphere is mostly carbon dioxide with some water vapour. Gravity is only 38% that of Earth, so a 50-kilogram suit would only weigh 19 kilograms on Mars. The surface is covered by a deep layer of fine-grained iron oxide dust, which is likely damaging to the human respiratory system and might wear through spacesuit seals. The Austrian Space Forum has conducted 12 missions to deserts around the world, and founder Dr. Gernot Gromer has been on all of them.
First of all, you have to understand a spacesuit simulator is like a spacecraft to wear for a human. It's a wearable computing device as well. So I would say like 50% of the project is mostly IT related. Now, that's what we see here. If you take a closer look here, for instance, we have sensors like you see O2, CO2 sensor, for instance. We have things to for communication, like the primary communication system, the backup communication system, because everything important like ventilation, like drinking in the spacesuit, or things like talking inside the spacesuit is so important and vital as oxygen to us that we need redundancy inside.
But I guess that's the big part of what you guys are doing. It's practicing all those workflows and protocols so that if something does go wrong, it's going to be okay.
Absolutely. The important thing is we love things to go wrong, but only here on Earth.
To prepare, analog astronauts are simulating missions on Earth. To earn their place, trainees must not only be the brightest and the best, they have to go through rigorous testing of their physical and mental abilities and their psychological strength. 50 people are brought in to run the tests, which include being set a complex task where the pressure is heightened by adding a time limit and increasing the number of people watching. Loaded up with around 50 kilos of weight, which represents the suit, they must go up and down stairs until they're physically exhausted before attempting complex tasks. And their patience and frustration buttons are pushed by counting out brown and white rice with chopsticks for no apparent reason.
We thought that everything was a test. You know, they did psychological interviews, regular interviews, physical tests, and you never knew exactly what they were testing for. You just kind of tried to be positive and do the best you can.
How do you react when you're in isolation?
I actually feel quite comfortable in isolation.
How do you cope under pressure?
How do I cope under pressure? I just think I try to do the best I can, and I realize that, you know, if for some reason I do make a mistake or there's some problem, I shouldn't be too hard on myself, because if there's that much pressure, then it's difficult. And so, you know, you can only give what you can, and you have to be okay with that. And then as long as you have that mentality, I think you tend to perform better while you're under pressure.
Do you have a tendency to panic?
Not that I know of.
Confined spaces don't trouble you?
I'm actually quite comfortable in confined spaces. Caves and such, I kind of find very exciting.
Anything scares you?
Probably some things scare me, but I haven't really found a pattern.
What you learn here, do you have any concerns about what you'd be facing, and can you achieve what they want you to achieve?
Well, that's of course always the concern. You know that they definitely pack the schedule full. There's not much time, there's lots to do, and the stakes are high, or the expectations are quite high.
Just before we put the goldfish bowl on your head, Robert, I just wanted to ask, is there a feeling of sort of a lack of control? Because you're not really in touch with your own body, are you?
Well, it's definitely a lot more difficult to move, and I'm wearing 3 layers of gloves, right? So anything I try to do is just quite very difficult. But within my range of motion, it's actually not so bad.
Yeah. And do you get slightly claustrophobic when the helmet goes on?
Well, I don't. I can imagine that some people would, but that was a certain part of the selection, that they don't take people who get claustrophobic easily.
While the 6 chosen analog astronauts carry out experiments and test hardware and processes in Israel, in Innsbruck, a support team of 15 to 20 people at a time will work shifts, simulating their roles during a Mars mission. The team takes good care of the analog astronauts' well-being. They have thought of everything. If we ever do colonise Mars, it will be a great place for tourism. Some of the solar system's most extreme geology can be found there. The red planet is half the diameter of Earth, but one of its volcanoes, Olympus Mons, is 3 times taller than Everest, and the base is around 600 kilometres wide, which means that, despite its great height, its slopes are only slightly steeper than a wheelchair ramp. To the southeast lies Valles Marineris, a network of chasms 4 times deeper and 5 times longer than America's Grand Canyon. At its widest, it's almost 322 kilometres across. Hellas Planitia is further east still and is one of the largest impact craters in the solar system. The basin floor is over 7,000 metres deep and extends around 2,300 kilometres east to west. During winter at the North Polar Cap, it's estimated 30% of atmospheric CO2 freezes out, adding a layer of ice or dry ice, which turns into vapour in summer. So when the astronauts are on their mission, are you recreating every single detail, even the delay back to mission control?
We have the mission architecture set up in a similar way like we'd have for Mars. So we have the field crew in the Negev Desert, but we also have a mission support center in Austria with all the flight controllers, engineers, flight planners, and so on. And they're communicating with a time delay of up to 20 minutes. Actually, if it's the furthest away of what Mars can be, typically it's about 10 minutes or so, which means you have to field forward a lot of the decision-making autonomy from the Austrian Space Forum's mission support center to the field as well. So the time delay, the limited bandwidth, the lack of reliability of communication satellites, for instance, these are all things we're recreating because it would be cheating if we just do it in our front yard in a big sandbox, basically. But if you allow for all those unknowns to take place, for all the weather uncertainties, there's also weather on Mars. It might not be raining on Mars, but there might be dust storms, for instance. And these are the unknown factors which test us to the point where we know we are reliable enough to go to Mars.
The Austrian Space Forum is funded by national and international research funding agencies and sponsorship. Next year, it's hoped a new, more streamlined spacesuit will also be ready to launch on the Israel mission.
We're working on our second generation of spacesuits. It's called Serenity, and it's a follow-up system to the Auda, which we've been working right now. It's a totally new generation, new game. It's like comparing a Ford T model against an electrical car nowadays or so. So what we're seeing here is a suit which is based upon 10 years of development of a predecessor model, which has advanced electronics, new power systems, new ventilation systems. It is what we call a rear entry suit, which means you don't need an airlock anymore. You basically attach the suit to the wall of a spacecraft, you step in from behind with an open life support backpack, basically. You close the backpack, you decouple, and you're outside, basically. That means you are mitigating the dust problematics, that you're not bringing in any dirt when you return from an extravehicular activity. It has many advantages. Also disadvantages, but that's what we're hoping for.
It's yet to be decided who will wear the spacesuit simulator Serenity, but the new analogue astronaut class of 2019 are waiting for the call after attending their graduation at the European Mars Conference in London. And many are happy to remain on Earth, doing the groundwork for the first astronauts to land on Mars.
If you'd say, well, would you go tomorrow if it's a possibility? Well, it sounds really exciting. I'd have to think about it though, when the actual realistic details of it come up and see what the mission actually looks like. And but it would be difficult to just say no off the bat.
Mars is not the final destination, it's the direction. It's turning humanity into a spacefaring species. If we do what we can do in our time, which is establish that first human foothold on Mars, then 500 years from now, there will be numerous new branches of human civilization on Mars, on hundreds of asteroids, and on hundreds of worlds circling other stars.
One of those groups is the Chinese space program, which has launched a rover to Mars. It's scheduled to touch down in 2021. When we think of space exploration, it's incredible to consider the modern smartphone has more computing power than the Apollo guidance computer or AGC that landed man on the moon. But it had one crucial advantage: it couldn't crash or freeze. In 1969, the AGC were at least 10 years ahead of their time. Produced for NASA's Apollo space program, it was installed on board each command and lunar module. But a smartphone has over 1 million times more memory and over 7 million times more storage. While our current mission operating systems control the computer and spread energy around different programs, in the AGC, each program's importance dictated how much energy it received. So in an emergency, crucial systems could jump the queue. Mars brings new challenges. With a communication delay of up to 22 minutes to Earth, rovers can only operate because of the development of more autonomous computers. The computer on board NASA's Spirit and Opportunity rovers was as powerful as a high-end laptop, but the microprocessor had to have radiation-hardened version of the PowerPC chip used in some models of Mac computers to deal with the planet's harsh atmosphere. The internal workings also needed to be protected to stop a freeze of the temperature kind. It's cocooned inside a gold-painted box, layered with insulating aerogel to keep components warm. And just as the Apollo missions pioneered technological advancements such as cardiac pumps, camera sensors and swipe card devices, Mars missions will continue the legacy of innovation. NASA's Mars 2020 rover will test making oxygen from the red planet's carbon dioxide atmosphere, paving the way for human interplanetary exploration.
The crew for Mars walks this planet already, and for them we are their shipbuilders in a way. So I don't know where this person would come from, if it's from Beijing or from New York or from Vienna, or who knows. I know I'd love to be with them, but although I'm only one of the shipbuilders enabling this voyage, I'm glad that they will make this journey, and they will make it. And it's my personal aim that when I'm retired one day, I'm sitting in my chair next to the chimney fire, and I have the 3D near real-time transmission of the first human landing. I can tell my grandchildren, I designed the little screw over there, and I was part of this adventure. I was one of the enablers, and that's a privilege I'm experiencing and living through every day of my work.
But we'll leave the final word to Carl Sagan, legendary astronomer and science communicator. Several months before his death in 1996, he composed a message to the future explorers of Mars.
I don't know why you're on Mars. Maybe you're there because we recognize that if there are human communities on many worlds, the chances of us being rendered extinct by some catastrophe on one world is much less. Or maybe we're on Mars because of the magnificent science that can be done there. The gates of the wonder world are opening in our time. Or maybe we're on Mars because we come, after all, from hunter-gatherers, and for 99.9% of our tenure on Earth, we've been wanderers, and the next place to wander to is Mars. But whatever the reason you're on Mars is, I'm glad you're there, and I wish I was with you.
It's finished. But don't worry, we've got a lot more Razor stories for you. All you need to do is like, comment and subscribe, and hit the bell button below for notifications. We'll see you next time.